Hi there, this is John Everest and this is the third tutorial on three-phase daylight calculations using Honeybee Plus for Grasshopper. Mega quick recap. So we looked at the sky we talked about how we make a sky matrix to control the daylight coming in, and we talked about the geometry presentation. I was sort of saying how really there's four types of geometry. There's two opaque types and two glass types. Opaque types are the envelope of your building, Honeybee surface. There's the context geometry, actually Honeybee surface, and yeah, yeah, Honeybee, there's the envelope of the building we're looking at. There's the context geometry, excuse me, context geometry, which is basically the surrounding environment. So that's going to be buildings, trees, landscape, whatever, the stuff that just is never going to change, totally beyond your control. And then we have the glass surfaces. We have the window, Honeybee window surface, which it becomes part of a calculation which I don't quite understand the purpose of. But basically, when you click calc, it will just immediately do a two-phase calc, even though this is a three-phase recipe. It will do a two-phase calc of these the room envelope, the context, and with any windows in here. You do not have to have windows here, but regardless, it will still try to do the calc. So it's I might be missing a trick. I don't understand. There's sorry, Honeybee window surface. I don't understand why it's happened. The Honeybee window groups are the ones that will be used in the true three-phase analysis calculations. You need to make sure that when you group, it can be one window on its own, or it can be multiple windows grouped together. Note that when you group them together, the light that is collected from the sky and in turn sent into the space will be it will be the same distribution and intensity from angles. If the window is bigger, then yeah, it will give more light from that window. But as I was saying before, is what you cannot do is sort of mix like windows that will give fundamentally different light distributions. You cannot. You could, if you had another one of these windows here, that's fine. You cannot mix that window and that window, or that window and that window, or because they're all at completely different orientations, and you will not get true results. Right. So that's that. Yeah, that's yeah. Oh, and over here is the XML file, which describes the by scattering distribution function files. Basically, this is you don't just put in a sheet of glass. You put in a surface, and then you use these files here. And get rid of that name. Use these files here to describe the distribution. So a clear sheet of glass, it will literally behave like a clear sheet of glass, or a diffuse sheet of glass, or it could behave like there's some blinds there, or a complex fenestration system. But yeah, what comes with the tutorial are these two types. Right. Okay. So when we hit calc, I'm going to hit calc, and the calc takes a while. So I'm going to talk you through the batch file while that's happening. So Honeybee 05. Let's call this John's walkthrough. Yep, walk through. Yes, and I don't know whether I think Honeybee does this for you anyway, but Radiance really, well, it will not accept gaps in text. But I think Honeybee fixes that for you. Right, first one is write the file. This takes a while. The reason it takes a while is because it's setting up a file structure, and I'm going to show you that in a moment. Personally, I just leave the folder. I think as well you have to leave a folder. I haven't tested this, but you can't have spaces in your folder address. So like say like if it was like John space folder, I think that would, unless Honeybee corrects that for you as well, that will crash. It will break the calc. So personally, I just like leave it to go into the. It'll just send it to the C ladybug folder. Everything's going to be good, right? So it's set it up, and I'm going to click calc, and off it goes. This is here to help, but to be honest, I don't. For me, it's not. It's for me. No, it's just not that useful. But let me show you the batch. Let me show you what's actually happening. Right, so if I go onto the C drive, so when we wrote that file, it wrote it to Ladybug. If you have Honeybee installed, um, uh, Honeybee and Ladybug installed, you'll have this folder here. You go in here, and I think I called it John's walkthrough. And what it's done is grid-based three-phase. It's set up the whole file structure for us. Yeah, so this is where the results go. This is where the scene geometry goes, and the sky stuff, and so forth. The 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 kind of like the director script, like a batch file is basically a set of automated controls to tell the computer to do something. Yeah, and what that whole recipe, yeah, when we were oh, Honeybee's locked now, so I can't touch on it. But when we were making the recipe, it was actually sort of like setting up and making this batch file. And this is the instructions to the computer of how to control radiance and what to give to radiance and what not, right? And I'm not going to go into this in any detail, but look here. So it's saying call the radiance program gen daylight matrix, yeah? And it's to get well basically this is like make it with the sun number sky divisions, don't rotate it, forget what those ones do actually, and this is the weather file. Do you remember I said you convert the Energy Plus weather file, the Energy Plus data file into a NWEA file and make a sky matrix from this, and you know, then it goes and does the same thing. I think that's a sunlight only calc, and so forth. And for those of you who the whole two-phase, three-phase thing makes sense, the first thing it's doing is when it goes through here, it's actually, like I say, it's doing a two-phase calc. Um, okay, there, look, and it calls it the scene default calc, but it is a two-phase DDS calc, including the windows you had in your Honeybee window surfaces, not Honeybee groups. And actually, I can just we can dig about and got its walk through glazing scene materials. I'm looking for the word black, because what it does is it makes the black material. So the windows for the three phase at this part of the calc, it's actually making sort of jet black sort of doppelganger versions of those materials, so you don't have a hole in your wall. So it's like you've got your wall and then you've just got this black surface. So be careful if obviously that could have an inaccuracy in your calculation. Okay, but it does that calc, and then it says, right, now I'm starting the three-phase calc. Well, thank you, because that's what I asked you to do. And and it goes through and it's going to do it for the south window, and it's oh, how much detail am I going to go into for this? Look, it's going to have the view matrix is basically the internal component of the calculation. The daylight matrix is the external component. It is very useful to be able to separate these two. You know, you'll have a different granularity for inside your room as you will in the external inside your room, and for your transmission through your window surface. Think about it. Inside your room, you might want an accuracy of, let's say, half a meter. Going through a set of blinds, you're going to want an accuracy of like a centimeter. And then outside, so I just need an accuracy of, generally I just need to make sure that I'm picking up these big buildings, but I don't need massive accuracy. I'm on an accuracy of like 1 or 2 meters, something very coarse. But if you did the whole calcs together, it's the smallest specification that rules. So if you wanted to get your rays of light accurately through a set of blinds, well, you're going to have to do everything to like a centimeter's accuracy. It is not feasible. If you separate it, you can literally calculate them all together, then add them all together at the end. That's what DC time step does. There's your view matrix, your transmission matrix, your window, and your daylight matrix. And I don't know why and then at the end of it you kind of need like the fuel is the sky matrix. So I don't know why it's not there. Echo means just write it, don't do it. This is like a comment. Like in Python, you go like you do the old, is it three things, and you write your comment. Echo is the command line version of that. Okay, and basically you go down. I'm not going to tell you how radiance works. So this is way beyond the scope. But so what I'm looking for now is, right, start of south window. Right, if I just do a ooh, whoop. South window, find next. Start of the three phase. Right, I'm looking for end of. Right, come on, you make my life difficult. End. Right, let me try that again and look for end. Basically, it shows you the start and the. Is it not for the scene? No. All right, maybe it doesn't. Okay, south window one. And it's going to show somewhere for skylight there, right? So it's done the south window. Yeah, there it is. So it's done the radiance matrix op. Radiance matrix start of the. Oh, there you go for the skylight. Yeah, it's very difficult to navigate. So basically, it's done the two phase, and I'm just going to dump all that because I don't. Well, in the tutorial it's been used, but when I'm doing my stuff, I just dump all that. Then it's going to do the three phase for the south windows, and then it's going to do the three phase for the skylight, yeah, and then it's going to sort of, and then back over on the Honeybee side we're going to compile all that data together. But it is very useful that they're all separate, so we can actually see what does the room look like without the skylight, what does the room look like with the south lights only, with the south facing windows only. And then remember, we had two states for that south face window. We had the just clear glass transmission and the diffuse glass transmission. We can explore all that stuff. I think I've been rambling on a while, haven't I? So I'm going to cut the video, and then I'll wait for the calc to finish, and we'll dive back in and look at what we can do with the results.